What is good, my analysts? Today we'll be looking at another JavaScript-based credential harvesting campaign. Continue to see these on the rise where we have HTML smuggling, which is just HTML pages with embedded JavaScript in there, and also continuing to see more and more of these phishing campaigns leveraging crypto.js to encrypt the content within the pages so that it makes it harder to analyze. Seeing this so much that I wanted to make another one of these videos so you can practice on how to analyze these yourself, so that you can pull out the tactical threat intelligence. So with that, let's just jump right into the sample. But here is the first stage of this credential harvesting campaign. What we see here is that we have this first variable being set to this, which is the targeted email address. I've removed it for the sake of the victim here, and then as well as a bunch of data that is written into three different variables as objects in an array, basically. Taking a look at this, you can say that probably can assume this is base64 data, but again, if you remember before, in JavaScript, ATOB is the base64 decode. So we can get positive confirmation this is base64 data. They're just concatenating it together. They're just using join to pull that together and then running that to eval to execute it. So very simple to start this out. We have done similar stuff like this before, and we can load it up here in Visual Studio or whatever your IDE choice is, as long as it has a debugger, especially one that you can do some web debugging. This makes it extraordinarily easy. So the first thing we want to do is we'll just comment this out so that we don't execute it, and we're just going to leverage console.log, which is, if you're more familiar with Python, this would be like a print statement. So basically what we're going to do is capture this ATOB to decrypt it, and we're going to pass that to console.log so that the base64 decoded data will now be available to us in the debugging console. So we're going to set a breakpoint here just to be safe in case there's something, messing around in there, but there's not much to this. We've already commented out eval, so nothing's going to execute. So let's go ahead and run this in the debugger. And boom, there we can see that we have the data written out here that is stored in base64. And taking a look at this, it looks like it is more JavaScript. We know that because document write is a JavaScript method to write, more web content to a page. And you're going to come across this more as you look into JavaScript payloads going in the future. We can also see this variable Goldfinch looks to be a concatenated string that's going to make a URL. So let's go ahead and stop debugging here, and just so we can make this easier, we're going to copy this and we will create a new file and copy it over there for further analysis. Now, one thing that I will recommend here as you do JavaScript is like this. You saw that I've saved it as HTML. This is just JavaScript, but to do this in a debugger to make your life a lot easier, if you're not super comfortable with debugging JavaScript, is we can just put it in script tags here. And now we have valid HTML. And now we can use our debugger again. So we have document write, and then we have ATOB, which means this is all going to be base64. Set timeout 4000. What this is basically going to probably do is write a new HTML file. It's going to wait 4 seconds. And then after that 4 seconds, it's going to do another document write, writing this as a script source. So it's going to redirect to this URL. Okay, so again, what we can do here is we're just going to set a breakpoint here. We will replace, we'll comment it out just so we can save it. We'll copy this down, and we're just going to do console.log again on the base64 data. And as long as I'm not covering up my, we have an extra parentheses there. Oh, we want to take out document right. Yep, see, I still do this live for you. So now we should be good. And then we're going to go ahead and debug this again and see what we got here. And here we go. And as suspected, we have a bunch of HTML data. Now this looks like just standard HTML. Very common in these campaigns is you'll see that it's going to write a page and then inject something else into the page to execute it, which is probably what exactly is happening here. In this case, we have a lure here for a voicemail. And if you read the blog, you will see that this was actually triggered by, a fake voicemail lure to get them to say, like, you have a voicemail, click on this link to go get it. And it says your browser does not support this audio element or whatever, but we have just raw HTML here, nothing suspicious really. So I'm guessing the only thing to be gained from this from a Intel point of view would be the URL, taking a look at what that looks like as it's being concatenated. So let's stop debugging here. And again, we'll set a breakpoint here and we will just do a console.log on Goldfinch and start debugging. And we get, here's the URL right here. And so it's pulling a PHP question mark and then some information here. Question mark, when you see this, guys, and you see the question marks in URLs, first assumption there is that this is some sort of parameter for this script. And then the other thing that I see, and you'll learn this as you look more at this, but this 687474707, this is very commonly a hex encoding string. Because this 687474, this will decode to HTTP://. And the more and more you look at this, you'll be able to pick these things out. And the other thing we notice there is there's all non-hexadecimal characters in here. So this is probably a hex encoded string. So let's take a look at that, and then we'll pull down a copy of this script here and take a look at what's going on there. Okay, so we can quickly do a hex decode. Now you could use CyberChef, you could use PowerShell, you could use, Bash here, whatever you want to do a hex decode. But that's basically all we're doing is on that parameter to the PHP script. We're just going to run this and see what it looks like. And boom. Okay, so we have another URL here. That looks sus.brew, that's always a good indicator, but we have it passing yet another URL to that script. So maybe it takes that as a parameter and then loads it into the content to go forward. But before we step on to taking a look at this URL, let's go ahead and take a look at that PHP file. So let me go ahead and grab a copy of that. Okay, was able to pull a copy of that from the host still, so we're going to go ahead and pop this open and take a look at what's going on in here. Okay, immediately recognize for what this is. Let me clear this debug console as we go through this. While it is listed as PHP in the file name, this is not PHP code. In fact, this is more JavaScript to take a look at. And we also see more our friend Crypto.js, which means that this is very common right now where the HTML smuggling that does JavaScript is also coming, that JavaScript is leveraging Crypto.js to encrypt the final payloads or one of the payloads to prevent analysis, usually through automated means. I don't know if you've tried this before, but like ChatGPT or any of the generative AI tools you can use for malware analysis, which are actually getting a lot better, still gets tripped up on decrypting data, even when you provide it, hey, look for this in the code. You got to really step through it. By the time you have got the generative AI to actually do, you've probably done 99% of the work on your own. So I think that that's why we're seeing this on the rise, because the automated tools are still tripping up on encrypted data. But the good news is in all cases like this, the decryption key has to be included in the code. Otherwise, it wouldn't work. So it's probably in this base64 data, just knowing here we see ATOB again. So that's a keyword that we can look for. And it's being saved to a bunch of different variables that are, so this is JSON data, and it takes each element in the JSON data and assigns it to ABCD as a variable. A is the encrypted data, and use C to decrypt it. So it's all in there, it's just hidden. But it's very easy to get to, so we can kind of decrypt this and see what's going on. Okay, so before we can go ahead and run this in the debugger to get the content of all of this information, I find it's a lot easier, again, with JavaScript, is just to load this into HTML so that we can use the browser-based debugging. Maybe you feel different about it, but I find it's really easy to do it this way. So we'll go ahead and create a new file. And again, just like we had to do before, all we got to do to make this valid so we can use the browser-based debugger is just enclose this in script tags. Okay, now for this one, instead of having to use console.log, we can actually just use the power of the debugger to get the information that we want. Just like the other ones, as we step through this, it's not really doing anything other than creating a new document. It's referencing Crypto.js, so it has the library, and then it's doing a base64 decode, reading it into those variables. So we'll set a breakpoint here and then get the contents of this. And we can do this with the native debugging because they are variable. So you'll see them pop up here on the left-hand side once it does. Yeah, so we hit our breakpoint, and now we can see, okay, here are our values, A, B, C, and D. A, yes, that looks like it's encrypted. These are just values, which are key values used in encryption and decryption, so that those normal values are just what they are. A looks to be the information that we need to get into so that we can find out what this thing does. This is the actual decryption function. And finally, it does a simple replace. Oh, it does a replace with RWUUQL. Now, this on dynamic load would work, right? But if I ran this right now, it's going to fail because it has no idea what this is. And we'd have to go back to the original page here to say, oh, this is set to the targeted email address. So I'm just going to come back in here. I'm going to stop my debugging, and I'm going to set this variable in the script so that it doesn't fail, and I can kind of step right through this without issue. So we have the base64 decoded that. We saw that they're just values. A has the encrypted content that we want. Here it is, we go through the encryption and decryption so that by the time we get to document right here, we'll have the fully decrypted data on how this works. And it's going to do just a replace on this string. Actually, let's, yeah, so we'll set our breakpoint right here. We know that we're going to get the values for A, B, C, and D already. if we did this, you'll just see that the strings are not going to be replaced. Actually, we'll set two breakpoints, and we'll start our debugger. And we're going to hit this. And if I go to here, I can just right click and I say evaluate, and we'll get more JavaScript. Okay, so here's our string, right? So it does a replace on this string with this email address, and then the rest of it is, just standard JavaScript. And here's that URL that was hex encoded as a parameter on that. So there's our j9q.ru/whatever, and then it goes off. So I'm going to step over this. We'll hit our next breakpoint, and I will evaluate this again. And now we'll see that it's probably been replaced, right? So we have our valid email address in here, and then all this is doing is saying if there is a pound sign or hashtag, whatever we call it nowadays, then if there's not one in the email address, then set the URL just to our .ru friend here. But if it does have a hashtag or pound sign, then we want to append a random uppercase letter and a hashtag pound sign. Then it's going to basically force a redirect by replacing everything in the web page with A, and then forcing it to load the next thing by forcing a mouse click. Okay. So that means that if we ran through this, it does have a pound sign or hashtag, so it's going to get a random letter. So let's, we'll copy this out, and we'll stop our debugger. We'll create a new file. Here, console, paste that in there. And we'll set some breakpoints because it doesn't really matter here. All we really want to know is what the URL is going to look like. So let's save this, and then I'm going to start my debugger. We get here, and if I evaluate URL, we just have a URL, right? So this is where this is the end game in terms of this chain of values, right? So no more, it doesn't look like it's going to be any more nested JSON that's loading things dynamically. It just go ahead and loads this. So let's go ahead and take a look at that. I already know how this ends because I saw the end game already. But if we load this, it's gonna take us to this sus. We're gonna get a CAPTCHA. We're still on this .ru domain, and there's a fake voicemail. None of these buttons appear to be valid. And if I click this, I'm going to get redirected to a Microsoft 365 credential page on this .ru. So this is more credential harvesting that we see. So that's it, guys. Like I went through that very quick, but it also, I feel like this is a skill that is gonna need to be like in everyone's bag of tricks here going forward, just because I'm seeing it more and more. Additionally, what I did is I created a little decoder script in case you're not comfortable running stuff in a debugger, but you're able to get the encryption and decryption values very easily, but you don't know how to use crypto.js, or maybe you just want to have something that you could automate with this. I wrote a very simple JavaScript thing that you could just run and it'll give you the decrypted content. So that's all I had for you today. Keep on practicing. I'll put these samples up so that you can work on them yourself and play around with them and get more comfortable. And as always, happy hunting.